Salutations, Honors Algebra 1. We are learning another method for solving quadratic equations. Woo! And by no surprise, we're talking about factoring because, like we said earlier, these were the four methods we were going to learn. We already did graphing, we talked about taking the square. Now we're going to talk about factoring. And I should mention there is another method here that we are not going to talk about in Algebra 1. It's called completing the square. You'll learn that in Algebra 2, but there are more methods than these four, just pointing that out. Okay, so before we get into solving quadratics, let's take a look at this. So I have some number, let's call it A, times some number, let's call it B, and I know that when you multiply them together, it equals 0. So if I know that A times B equals 0, what can you deduce? What do you just know automatically? Well, if we know that two numbers, when you multiply them together, gives you 0, that means that one of them needs to be 0, right? Because if they're not, if you have like 4 times 7 or anything other than 0, you're not going to get 0. So at least one of these needs to equal 0. So either B equals 0 or A equals 0, or maybe they both do. So what about if I replace A with this and I replace B with this? But remember, we're still multiplying, right? We're still doing this times this. And you know that the answer is 0. Well, the same thing applies here, right? Since I'm doing this times this and it equals 0, that means that either the stuff I circled in the first circle equals 0 or this stuff equals 0. So, or maybe both of them do. So we have two possibilities. Let's set both of these equal to 0 and see what both of the possible answers are that we might have. So maybe x minus 5 equals 0, or maybe x minus 1 equals 0. Well, since in this case we want to actually solve for x, what we could do now is solve this little mini equation, and we get x equals 5. And let's solve this little mini equation, and we get x equals 1. So this is what we're going to see today. Believe it or not, this is a quadratic equation. The difference is somebody went and factored it, and we're going to have to do that as well. But before we get there, this is called the zero product property, and this is what we're using every single time we solve something today. If you have something times something equals 0, then either A equals 0 or B equals 0. Okay, ready to move on? Let's do example 1 together. So it tells us to solve for x. Go ahead and write it down. All right, so I have this in the first parentheses times this in the second parentheses equals 0. That means either this equals 0 or this equals 0. So what we're going to do is we're going to set both of these separately equal to 0. All right, now we need to actually solve these equations. Don't jump ahead real fast and accidentally say that x equals -2, because remember, you would need to actually add 2 to both sides, and you get x equals +2. And this one we get x equals -14. All right, sweet. Just like before, we get two solutions. How can you test to make sure that they're true? Well, you can test both of them by plugging them back in and make sure that it equals 0. And they both will. Let's do example 2. Same idea here. I have this times this, and it equals 0. So either the blue stuff or the red stuff equals 0. So we're going to take a second and write them both out, set them both equal to 0. Okay, now we have two equations that we need to solve. They're two-step equations this time, so hopefully you haven't forgotten how to solve those. On this one, I'm going to subtract 4 first, then I'll divide both sides by 3. All right, and our rule of thumb for this section is we're going to leave our answers as simplified fractions. So don't change this into a decimal. Your answer is -4/3. It's less work for you. Just leave it -4/3. And this one we get a fraction as well, x equals 1/2. Alrighty, nothing too crazy here. But what if they give us one and they tell us to solve it by factoring, but it doesn't already look like something times something? Well, the good news is we learn how to do that, right? We learn how to take polynomials that look like this and change them into two binomials multiplied together. So I'm looking for factors of 20 that when you add them up give you 9. So it must be 5 times 4. So I'm going to rewrite this side then as x plus 5 times x plus 4. All right, and it still is equal to 0, so keep that equals 0 there. Awesome. Now it looks just like the other ones. I can set this side equal to 0, and I can set this one equal to 0. So here are the steps that you will need to follow if it's not already factored for you. First, make sure it's set equal to 0. The last one that we just saw was. Then try factoring out any greatest common factors first. So look, hey, can you pull out an x cubed from all of them or something? And then lastly, factor the remaining polynomial. In the last example, this is the only one I had to do. Okay, let's look at another purple example. So I have n squared minus 57 equals 7. Okay, step 1, ensure that it is set equal to 0. This one is not set equal to 0, it's equal to 7. So I'm going to subtract 7 from both sides first. Okay, step 2, see if there are any common factors I can pull out. This is n squared, this is 64. There's nothing I can pull out of both of those terms, so nothing for number 2. Step 3, I factor the polynomial. Now, this is one of those weird ones, right? Because we're missing the middle term. So if it helps, you can think about it like this. This is really n squared plus 0n minus 64. So we're looking for factors of negative 64 that add up to 0. And right away, I know they must be the same number. So it has to be 8 and negative 8. Okay, awesome. Here's my factored form. So now I'm going to set both of these equal to 0, n plus 8, n minus 8. And there we go. I'm assuming that most of you at this point can see right away, oh, n equals 8 and negative 8. So you don't need to show this necessarily. And remember, if we get two answers that happen to be the same number, one positive and one negative, you could just instead say n equals positive or negative 8. That's okay too. Let's do example 3 together. Okay, so I need to make sure it's set equal to 0. Hey, it is this time. That's good. I need to check if I can factor anything out of each term. Well, I can't pull out any n's because this one doesn't have any n's. I can't pull out any numbers because this one just has a 1 out front, so nothing to pull out. So I need to factor this polynomial instead. All right, good. It's all positive, so that makes it nice and easy. I'm looking for factors of 40 that add up to 13. Well, they must be 5 and 8. Cool. Now what? Well, now we have either this equals 0 or this equals 0. So that means n equals negative 5 or n equals negative 8. Let's do another one. Okay, let's follow our steps. Is it equal to 0? Yes, that's done. Is there anything I can factor out? No, not on this one because this one doesn't have any x's. I can't pull a 7 out of everything. There's nothing else I can pull out of 7. So no, nothing to factor out. So I need to factor this guy. But be careful because there is a coefficient out front. Remember, what do we need to do with this 7? It's been a while, but yeah, we need to multiply it to the back. Equals 0. All right, fun. So now I'm looking for factors of 210. All positive again, so that's lucky. Where when I add them up, I get 47. And it looks like it's going to be 5 times 42. And again, just sit there and experiment. Get out a calculator, divide it by 3 and see if the two numbers add up to 47. Divided by 6, divided by 10, you know. Just sit there, guess, and check until you find them. Okay, so it's really tempting to, at this point, just jump to, oh, okay, so x plus 5 equals 0, x plus 42 equals 0. But what step are we forgetting? We need to divide back out by the 7. Anytime you multiply to the back, you got to divide back out. All right, so remember, if you can simplify, do it. If not, move your denominator out front. So this one's going to be 7x plus 5. This one is 6. Great. Now we can go ahead and set each of these equal to 0 separately. And now I'm going to solve both of these little equations. First one, I got a fraction. I'm leaving it as a simplified fraction, -5/7. Second one, I just get -6. Yay, awesome. So be very careful. Be on the lookout for those where you have to multiply to the back. Don't forget to divide back out. Last one, example 5. We'll just do this one together as well. All right, so what's the first thing I'm going to need to do here? Oh, well, it's not set equal to 0, right? It's set equal to -8. So how do I make this side equal 0? Well, I need to add 8 to get it to equal 0. So I'm going to add 8 to both sides. This side equals 0 now. Now on this side, be careful. I have -8 plus 8. That's also going to be 0. So I don't have anything here anymore. So I just have the g squared plus 4g. 4G network. Okay. So now, step 2, look and see, is there anything you can factor out? I have a g squared plus 4g. This time there is something I can factor out, right? Because they both have a g in them. So I'm going to pull a g out front. I'm going to undistribute a g. So this first term will just be g. And this term, I'm pulling out a g, so I'm just going to be left with a 4. It still equals 0. Okay, this one looks a little bit different, but I do still have two things multiplied together. I have g times g plus 4. So either this equals 0 or this equals 0. So I'm going to set both of these equal to 0. So when I set g equal to 0, hey, it was just already solved for g equals 0. With my other one, I needed to do one step to solve, and I ended up with g equals -4. All right, so there's our two solutions this time as well.